Hello everyone and welcome again. In today's video we'll have a look at how to blink LEDs, how to change the states from high to low using a delay command. So let's go and have a look at our connections. So this is what we're going to be doing. We've got our PIC F2220 that we'll be using for the next few videos. We've got our LEDs, they occupy the full port C. So we've got 8 bits on the port C, 8 LEDs connected through the current limiting resistor. These are 470 ohms resistor to the ground, and I've made some connections, some permanent connections to the PIC kit programmer, so I will be using them all the time. Therefore I'll be avoiding using a port B, those programming bits, and as well as MCLR. So we're not going to be clearing the PIC, we're not going to be resetting the PIC. Okay, so let's go to the code. Let's start a new project. Okay, standalone. Next. Now we know this is advanced 8-bit microcontroller. We can select 18F2220. There we go. And I'm using PIC kit 4, so I'll be using that one. Next, my compiler, the project name. So the project, let's call it blinking diodes, just something different. Okay, so I'm gonna set this as a main project. Okay, just one thing, let's try to avoid the empty spaces between the names. Compiler doesn't like it, so I just put the underscore there. Okay, I'm happy with the location for a file. I'm gonna finish it. Okay, right, as we know, we go into the source file and we have to create the new main.c, and a new main.c. I'm just call it blinking. Okay, leave it like that. Click finish. So this is the file. I'm just gonna delete all this and delete that as well. Nothing to return. Make it a bit bigger. So now where to start is we're going to the production and we set in the configuration bits. So these are all the configuration bits for our PIC 18F2220. What's the important is that we're going to be using internal oscillator. This is going to be very important for us. Okay, and now the rest of it I'm going to switch it off. Okay, so everything is now switched off, whatever I don't need. I'm going to generate the source code. I'm going to copy all this what was generated. Okay, copy, and I'm going to paste it just above that. Now we can make this a little bit smaller. Right, we've got our code, we've got our main file, and now the first thing that we need to set is the setup for the for the oscillator. So what to do that? Let's go to our data sheet. Make this a little bit smaller. Bring the data sheet. Okay. So we go down. We've got our pinout for our PIC that we're using. So we know this is there's 4 bits there, 4 bits here. This is the ones that we're going to be using. Now let's go down and oscillator configurations. So in here we have to go down to the OSCON register. There we go, that was lucky. Quick. Okay, so the OSCON register has got 8 bits. So we can see here 1, 2, 3, 4, 5, 6, 7, 8. Okay, so obviously from bit 0 to 7. Now we could probably just set this register and it will be fine, but let's have a look at all of them and set them. In our code, what we're gonna say is the name of the register, which is OSCON. There we go. Now we're gonna set this in binary, so it's easier to explain. I'm going from the highest bit, from bit 7. We've got this I'll enable bit. We can set this one to 0, so we choosing this option. So I'm gonna say sorry, 0. Yes. Now the next one, this is very important. We got 3 bits, and we have to select the 8 megahertz internal oscillator. So we set in all 3 bits to 1, so we say 1 1 1. Now after that, the next one, we say 0, so that's where we're going with this, 0. Now we've got this bit 2, so bit 2 we set into 1, so the frequency is stable. We can use that bit for a check-in as well, but we'll have a look at this later. Okay, and the last 2 bits, so this one we're using the internal oscillator block, and we're gonna set this one to 1 0. Okay, that's it. So that's our oscillator control register set. That's where we're gonna leave it. If you're interested, this in hexadecimal is 76, so you can set it and type it 76. It's going to be shorter than that, right? And next what we're going to set is our choice register, so we can say choice C, because that's what we're going to be using, is equal to, we want this all to be output, so I'm just going to say hex, so decimals, it all zeros, 0 for outputs, 0 looks like O. Okay, now I'm going to make a little space here. We know that we're going to be using the lat registers, so we're using ports to read from, and we're using lat to write to. Okay, so now let's maybe bring this down a little bit. Okay, and now let's have a look at our connections, so what we have on our breadboard. So this is that. What we have here is, I've got the power supply to the breadboard, I've got PIC 4. Now these connections are permanent connections, kind of a hardwired there. Okay, so I've got the PIC 18F2220, which is going to stay there for a moment. I'm going to zoom in a moment to maybe be better. Power supply to the PIC there and there. And here what we have is, I've got the full port C connected to the LEDs, and they're going through the resistors network. There we go, 470 ohms resistor network I'm gonna be using for that. I've made this little explanation of what's gonna be happening, so it's gonna be easier for us to read. This is RC0 to 7, so if any of those diodes blinks, then we know which one it is. I'm gonna zoom in a little bit more. Okay, so there we go. So that's what's the most important part for us in this video. Now let's go to coding. Okay, so what we're gonna say is we would like lat C bits, okay, dot. Now C0, let's just practice on this C0 for a moment, to be 0. Okay, it's gonna be off anyway, but let's say 0. Now the code, what we're going to be using, the instruction is double underscore delay underscore. Now I could use milliseconds, or if I'm doing some advanced coding programming, I could use microseconds. Well, we're using milliseconds, so it's going to be visible. Microseconds won't be visible to us. In the brackets, we're saying what's the delay in milliseconds. So obviously from 0 maximum, what we can read in a XC8 compiler, what it says is around 500 milliseconds use maximum delay, so that is recommended. Larger than that, to a few seconds. We're going to create that when we'll be looking at the loops, how to create the loop. Okay, so now the compiler accepted the delay millisecond, but if we try to build the program we're gonna encounter the error because we did not identify this, the frequency. We didn't say we have to define it just after the XC8. We have to say hashtag, and then we have to say define, okay, underscore xtal, okay, frequency, and so we're using 8 megahertz, which is 8 millions, 1 2 3 1 2 3. So this this instruction XC8 compiler allows us to use, but providing that we specify the frequency for the oscillator that we're using, whether it's 1 megahertz, 4, 8, we have to say what is it so the delay can be calculated. So this little macro is very useful, but there is a condition to be met first. Let's build it now and have a look what's happening. Great, now the program is building, no problem. So I'm just going to copy this, okay, and I'm going to paste it here, paste, and again let's paste. Okay, so at C0, okay, C0 starts as 0. Now I've got 500 millisecond break. Now I'm going to say switch it on, which is 1. Now switch it off, switch it on. Okay, so because now at the end of this code we've got no loops here, no for, no while loop, so the program will be looping itself. It's not the best practice to do, but we're gonna keep it like that for a moment. Okay, so let's build the program. I've got my PIC kit connected, so let's build it, connect to the PIC as well, and let's see what's happening. Connecting to the programmer. Okay, I'm gonna switch this message off now. Great. Now as we can see, the C0 LED is blinking in the intervals of 500 milliseconds, on and off, on and off. This is because this is not, there's no termination like we said there. There's no loop that the program can stop at, but it's just looping itself. Okay, so we know this is working well. Let's try now, and let's go to program a little bit more of these pins. Okay, so let's copy all this, copy, paste. I'm gonna change this one, so we go on, and now let's go C3, 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 and C3. Okay, let's build and program at the same time. Let's see what's happening. So we're using C0 and C3. Okay. So what is happening now is the C0 is blinking off, on, off, on, stays on, and now C3 is off, on, stays on, and C0 is blinking. Okay, just please remember, using a C coding, you can write any program few different ways, and some of the ways are quicker, some of the ways are much more explanatory, some are just a preference. So I'm using this way just so we'll understand what's happening. Maybe let's make a slight break between the different ports, different pins, sorry. Okay, let me copy this. I'm gonna paste here. We're gonna use C5 now, let's say. Okay, C5, C5, C5. Okay, let's build and program. Okay, so this is done, and C5 now. So as we can see, everything is working well, everything's working fine. Just please remember as well, we're using LEDs to highlight the state of the pins, high or low, but instead of LEDs, as we can see, as we will see later on, we'll be using different devices to switch them on and off. LED is just a very good indication of the state of the pin we're using. Now let's make just a final program to complete this video. Okay, so I wrote some program just for a completion and testing all the bits. So let's make sure that the PIC is okay, all the bits are working fine. So I'm gonna just build it, and we're gonna have a look talk about this in a moment, what is happening. So I'm building and programming at the same time. And this is the program. So as we can see, what it does is got some break, some delays, and it's switching all the bits one after another. Really, we shouldn't be doing this because we may draw too much current from the PIC and possibly destroy it. But because of the LEDs and resistor, it's kind of okay. Still, let's try to avoid this for the future. Okay, so what the program does is switching all the pins one after the other. Then we've got 2 seconds delay. I've copied the instructions and pasted them in. So it's on a half-second delay, sorry, and then switching them on one after another off. We've got 2-second delay, 4 times 500 milliseconds, and then it goes back to the top and switching them off and on after one after another. Okay, thank you very much. If you've got any questions, please post them underneath the video and I'll try to address them as soon as possible, and I will see you all in the next video. Thank you very much. Bye.